This is the Unit 2 study guide. And here we go. So first we have some inequalities. We're starting with the ands. First thing we're going to do is we're going to divide by -5 on both sides. Because we're dividing by a negative number, our inequality sign is going to flip around and give you +2. The other side, I'm going to subtract 6. Gives me -3. It's less than or equal to x. I'm going to put my x on the left-hand side and flip everything around. Notice my inequality sign flips as well. I like my variables on the left so I can use the inequality sign to help me graph. So I'm going to have a bracket at -3, a parentheses at +2, and it is an and. So I'm going to graph in between them, which is exactly what I want because that's where they overlap. My interval notation will be -3 to 2 with the parentheses. Just like that. Number 2. Another and. I'm going to subtract 1, which gives me 3x is less than or equal to 1 divided by 3. X will be less than or equal to 1/3. The other side, I'm going to add 3. To get -x is less than or equal to 5. Again, we have to divide by -1. So x will be greater than or equal to -5. Again, notice how I divided by a negative number and my sign flipped. Notice in the first part, I subtracted a number and nothing happened to the inequality sign. So I'm going to have a bracket at -5, a bracket at 1/3. And since, again, it is an and the two graphs need to cross, so I have this, where they cross, or they overlap. So we have -5 with a bracket to 1/3 with a parenthesis, or sorry, with a bracket as well. And that's it. Number 3. Now we have an or inequality, so this is where they do not need to overlap. So I'm going to actually subtract 3x from both sides. So I get -2 greater than or equal to -1 x. I'm going to divide both sides by -1 to get 2. Because I divided by -1, I'm going to flip the sign. I get x, and then I'm going to flip it again so I get my x on the left-hand side. And so the inequality is still pointing at 2, and now it's still pointing at 2 below it, so that's correct. On the right side, I'm going to subtract 7. -4x is greater than or equal to 4. Divide by -4. Again, because I'm dividing by a negative number, the inequality sign will flip around. Okay, so now we have a bracket at -1 going to the left, a bracket at +2 going to the right. And because this is an or, that's fine. So I'll have a parentheses at -infinity to -1 with a bracket, a break, a bracket at 2 to infinity, and parentheses. Number 4. Again, we have an or. We're going to subtract 4 from both sides. So you get 3x greater than or equal to +2. Divide by 3. X will be greater than or equal to 2/3. Over here, we're going to subtract 3 from both sides. 4x is greater than or equal to 8. Divided by 4. X will be greater than or equal to 2. Okay, so we have a bracket at, where are we at? 2/3. A bracket at 2. They're going both in the same direction. Since they don't need to overlap, that's fine. So we're going to have a bracket at 2/3 going towards infinity, with the parentheses. All right. Number 5. Number 5, we have a compound inequality, but it's a simple version. All compounds are going to be ands. So I'm going to write that down. I'm going to add 9 to all 3 sides. So I'm going to get 14 x and 21. Okay, so I have 21 with a bracket. Yep, it's on a 1. I have 14 with a bracket. We're going to graph in between them. How you figure out which direction it's going, you might want to like flip around the x and the 14 so that the x is on the left. So whatever works for you, you can do. So 14 to 21 brackets. All right, next one. Another compound. It's again an and. Subtracting 7 from both sides. You get negative 3, 2x, and 6. Divide everything by 2. So I'll get negative, there we go, sorry. Negative 3 over 2, x, and 3. So we have a bracket, a parentheses at 3, a bracket at negative 3 over 2. This is an and, it's where they overlap. And there we go. That is our interval notation. So for these problems, all the ones we've done so far, it's 5.1, indicator 5.1 to solve it, and then the graph and the interval notation is indicator 7.2. All right. Next we have the more complex compounds. These are again and problems. Okay, now to solve these, we have to break these up into 2 pieces. So here's the first piece, all the left and all the middle. So let's put that part down first. So we're going to have 3 plus 5x, and 4x minus 2. We can solve this out. So we're going to subtract 4x, and subtract 3. So that goes away, so we're left with x less than or equal to and negative 5. Okay, so that's the first part. The second part, let's do red. We're going to do the middle and then the right side. Notice the whole middle gets done twice. So 4x minus 2, 3 minus x. So I'm going to add 2 to both sides and add x. So I have 5x is less than or equal to 5. Divide by 5, and x will be less than or equal to 1. So we have a bracket with 1. Another bracket with 5. Negative 5, sorry. Now, this is an and they only start overlapping when you get to negative 5. So we're going to actually erase. Let's do this instead. Up. Right there. We're going to erase the 1 because that's not where they overlap. They start overlapping at negative 5. So that becomes your interval notation. Okay, that's the only place where the 2 graphs will overlap, is at negative 5 going to the left towards negative infinity. All right, same idea, another complex compound fraction. Again, this is an and. So we're going to do the same thing. We'll be consistent with our pattern. So we have the left side and then the middle. So let's put that one down first. We have x plus 2. Let's make this a little bigger. X plus 2 2x minus 3. Solve that out. Subtract 2x. Subtract 2. Those go, those go. So we have negative x is less than or equal to negative 5. Divided by negative 1. Dividing by negative 1. Switches my inequality sign to be greater than or equal to. That's our first equation, our first inequality. Now we're going to do the middle, the 2x minus 3 and the x plus 8. That's my second equation, or inequality. So we have 2x plus 3, or sorry, minus 3, less than or equal to x plus 8. So I'm going to subtract x, add 3. I get x is less than or equal to 11. So I have 11 with a bracket, 5 with a bracket, and they're approaching each other. That's where they overlap. So we have 5 and 11. All right, now on to the absolute value inequalities. Okay, before we can figure out what type this is and what to do with it, we have to get the absolute value brackets by themselves. To do this, we're subtracting 2. So we get 3x plus 2 and 8. Okay, now, in looking at the inequality sign, this is a great, let's do it this way, a great or. All right, so it's an or problem because of the inequality sign that we're given. What we can also do is now split our inequality up, or our absolute value inequality, into two separate inequalities. So we have 3x plus 2 is greater than or equal to 8. 3x plus 2 is less than or equal to negative 8. Notice when we made the 8 a negative, we also switched around the inequality sign. We flipped it upside down, flipped it around. Okay, so now we solve both. So we get subtract 2 from both sides. So 3x is greater than or equal to 6. Divided by 3. X is greater than or equal to 2. On the other side, subtract 2. Negative 10. 3x divided by 3. X will be less than or equal to negative 10 over 3. Okay, so we have a bracket at negative 10 over 3. We have a bracket at positive 2. They are facing away from each other, which is fine because it's an OR. Then we write our notation from negative infinity to negative 10 over 3 with a bracket, a break, a bracket from 2 to positive infinity. Right. And number 10, this one's already solved. Not solved, but it's already got the absolute value brackets isolated. All right, and this is a less than. This is an and problem. So, because it's already isolated, we can make our two separate inequalities. Yep, wrong way. When I made the 7 into a negative, I flipped around the inequality sign. So I add 3. 2x is less than 10. Divide by 2. X is less than 5. On the other side, add 3. 2x is greater than negative 4. Divide by 2. X is greater than negative 2. All right, as an and, that's where they overlap, and that's what we write down for interval notation. And we are done with inequalities. Next, we're moving on to quadratic equations. Okay, so we're going to solve this using any method. I'm going to show you the most efficient methods to use for each one of these. So this looks like a factoring problem. 3 times negative 10 is negative 30. Two numbers that multiply to be 30 and added to be 4. It's divided by 5. No, that'd give me 6. Divided by 2. Okay, so here's the problem. No factor is going to give me, no two numbers are going to multiply to be negative 30 and add up to be positive 4. And since there's no factors, it means this is the quadratic form of the problem. So I'm going to put negative 4 plus or minus square root of 4 squared minus 4 times 3 times negative 10, all divided by 2 times the a, which is 3. Okay. Remember, you need to memorize the quadratic formula. It's not going to be given to you on the test. So if we simplify this, we have negative 4 plus or minus. I'm going to put 4 squared minus 4 times 3 times negative 10 gives me 136 over 6. Now I do want to try and see if I can reduce the square root of 136 by a perfect square. Let's try 4, and that works. 4 times 34. Square root of 4 is 2. So I'm going to have negative 4 plus or minus the square root of 4 is 2. And the square root of 34 is left over, all divided by 6. We got one more step. The negative 4, the 2, and the 6 are all divisible by 2, so I'm going to reduce those as well. I'm going to get negative 2 plus or minus square root of 34 divided by 3. And this is your final answer. All right, next one. 3 times negative 2 is negative 6. The factors of negative 6 that will give me negative x, or negative 1, would be negative 3, positive 2. Okay, so negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. Now I divide these both by my first term, which was 3. And then I reduce. So I get negative 1 over 1. I'm going to leave it as a fraction. And 2 over 3. Put the x's in the bottom. So I get x minus 1, 3x plus 2. And I take each one of the factors, set it equal to 0, and solve. So I will get x is equal to 1 and negative 2/3. (13). Two numbers that multiply to be negative 72 and add up to be negative 1. Negative 9, positive 8. So if I set those equal to 0 and solve, I'm going to get positive 9 and negative 8. Yeah, this is a solving using square roots. I'm going to add by 7. So I'm going to get 4x squared equals, that would be 23. Divide both sides by 4. All right, and just real quick, when we're doing these types of problems, the main concern you have is you need to get this x squared by itself. Okay, so to back up for a second there. So that's what we're doing. Okay, you can't square root both sides of the equation with the 4 on front of it. X squared has to be by itself. Now that we divided by 4, that goes away, so x squared is by itself. We have 23, that's not 3, over 4. Now we can square root both sides. Square root and the square root would go away. X is equal to plus or minus. All right, now in this case, and one of the rules of math is you're not supposed to have square roots on the bottom of your fractions. Luckily for us, the square root of 4 is just 2. So we're going to be left with the square root of 23. My 3's are doing bad tonight. Over 2. And that would be our answer. All right, number 15. 2 times negative 31 is negative 62. Let's put that in the calculator, see what we get. Negative 62 divided by, actually, you know what? There are no other factors because 31 is a prime number and so is 2, which means there are no other factors for 62 besides 2 and 31. So this is not factorable either, so I want to put this in the quadratic formula. So I have negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So I'm going to put what's underneath the square root sign in the calculator. So 9 squared minus 4 times 2 times negative 31. So 329. Okay, now I'm going to check and see if I can't make that smaller. So I'm going to divide it by perfect squares. I don't think 4 is going to work, but I'll try it anyway. It didn't. Okay. My next choice would be to divide it by 9. That didn't work. Next choice would be divide it by... So if 4 doesn't work, so then neither does 16. 5's not going to work because it's not a multiple of 0 or 5. 329 is not. 6 won't work because 4 didn't go into it, so 36 wouldn't work. My next guess would be 49 for 7 times 7. That doesn't work either. So my guess is there are no perfect square factors inside 329. So this becomes your answer. All right. 16. 5 times negative 14 is negative 70. 2 factors that gives you negative 70 but add up to be 33, negative 33. Negative 35 and 2. I'm going to take my first term here, and use that as my denominator of my fractions. So I'm going to get negative 7 over 1, 2 over 5, put down the x's, bring them to the top, get x minus 7, 5x plus 2, equals 0, x will equal 7, and negative 2/5. Another very simple factoring. 2 numbers that multiply to be 72 but add up to be 17. 9 and 8. So x will equal negative 9 and negative 8. All right. Last quadratic here. We need to get the x squared by itself. Everything that's not in red has to be on the right hand side. So we're going to add 7 first. So we're going to get 18. Okay. X squared is still not by itself, so we're going to divide by 2. And now we can square root it because the x squared is by itself. Square and the square root go away. X is equal to plus or minus. The square root of 9 is just 3. All right, on to some of the other different types of equations. First, we have fractionals. So in these, again, you want to factor the numerator and the denominator, the bottom and the top of the equation. So we have 2 numbers that multiply to be negative 4 and add up to be positive 3 would be positive 4 and negative 1. On the bottom, 2 numbers that multiply to be negative 12 but add up to be positive 4 would be positive 6, negative 2. Okay, now you can see that none of these expressions are the same. So what do we do at the bottom? Absolutely nothing. Right, we're only solving the top. So we have x is equal to negative 4 and positive 1 from the top. I don't care what the bottom is. It can't cancel anything, so we leave it alone. 20. All right, so 2 numbers that multiply to be negative 10 but add up to be positive 3, 5, and negative 2. On the bottom, numbers that add up to 15, multiply to 15 and add up to 8, 5, and 3. Since our x plus 5s in the numerator and the denominator are the same, we cross them out. All right, and the x plus 3 on the bottom, we ignore. So we have x minus 2, set equal to 0, and x equals 2. And that is our answer. Last one of these. Again, we're factoring. 2 Two numbers that multiply to be 20 but added to be -9 would be -5 and -4. On the bottom, in the denominator, two numbers to multiply to be -3 and add up to be +2 would be +3, -1. Again, nothing cancels, so we're just solving the tops. So x will equal 5 and 4. Right. Some radical equations. So we need to get the radical sign by itself first, which it already is. And now that it is, we can just square both sides of my equation. Start off with x plus 7 equals 2 squared is 4. All right, subtract 7 from both sides, and x will equal -3. Okay, as a radical, you want to check this out. So -3 in for the x. -3 plus 7 is +4. The square root of 4 is 2. That's what the other side equals. So this works out. Next one. Before we can square both sides, kind of like the absolute value equations, we have to get the square root sign by itself. Okay, and right now that -4 is there, so we got to move it. And add 4. So we're going to get the square root of x minus 3 equals 3. Now, since the square root sign is isolated and by itself, we can square both sides of the equation. The square root and the square root cancel each other out. X minus 3 is equal to 9. We add 3 to both sides, and x will equal 12. If you want to put that in the equation, 12 minus 3 is 9. The square root of 9 is 3, and 3 minus 4 is -1, and that checks out. All right, same idea as the last one. I got to get the square root sign isolated, so I have to subtract 5, which gives me 3. Struggling with the 3. There we go. I can square both sides. So I get 2x minus 3 equals 9. I'm going to add 3. Gives me 12. And 2x. Divide by 2 on both sides, and x will equal 6. So we can check it out. 2 times 6 is 12. 12 minus 3 is 9. The square root of 9 is 3. And 3 plus 5 is 8. So that checks out. All right, kind of like some of the problems with radicals, some very common characteristics. The brackets must be alone before you can start making two separate equations. You have to add by 2 on both sides. So we're going to get the absolute value of 3x plus 4 equals 13. Now that the brackets are by themselves, we can make our two separate equations. 3x plus 4 equals 13. 3x plus 4 equals -13. Now we just solve. Subtract 4 from both sides. Get 9 and 3x. Divide by 3. X will equal 3. On the other side, subtract by 4. So you get 3x is equal to -17 divided by 3. X will be equal to -17 over 3. Okay. Based on the absolute values and the properties of them, you don't need to check this one if you don't really want to. They will both work. It can't be said, though, for the next one. You're going to have to check this one because there's an x on the outside of the brackets. Okay, so this is already isolated, so we can make our two equations. So we have x minus 8 is equal to x plus 2, and x minus 8 is equal to negative, and then in parentheses, x plus 2. Got to put, out of 3. Got to put the entire expression in parentheses and then put a negative sign on the outside of it, because you have to distribute that negative sign to all the terms inside the parentheses. So we have negative x minus x. Those go away. That goes away. So you have -8 is equal to +2. That is not a true statement, so that does not have an answer for that particular equation part. And that's fine. Sometimes it happens in math. The other one, we have x minus 8 is equal to negative times x is negative x. Negative times 2 is -2. So I'm going to add x and add 8. So I'm going to get 2x is equal to 6. Divide both sides by 2. X will equal 3. All right, now you do have to check this one because there is an x on the outside of the brackets. Okay, so if I put 3 in for the x's, 3 minus 8 is negative 5. The absolute value of negative 5 is positive 5. So is that what the other side equals? Well, 3 plus 2 is 5. So since it's 5 and 5, this is an answer. So that does work. All right, now this last one's a pretty interesting example. Okay, if you remember back to the time we did absolute value equations, absolute values, by definition, spit out a positive number. So if in this case you have a negative 2 equaling an absolute value, that can't happen. So without actually doing any work, this is a no solution. Because, an absolute value cannot equal a negative number. Okay? And notice, the absolute value is by itself. There's nothing else around it. It's just the absolute value bracket itself can't equal a negative number. All right. Word problems. Oh, so fun. Here we go. Rectangular picture has dimensions of 20 by 10, 10 by 20. Here's my picture, 10 by 20. There's a frame of uniform width around it. This is X. Let's make this bigger. This is X, X, X. So my dimensions would be 2x plus 20 and 2x plus 10. All right. Like in previous problems, this is 1.1 or indicator 1.1 for drawing a good picture. That's what it should look like, ladies and gentlemen. Next, we have to make our equation. So I know length times width is going to be for the area of a rectangle. So we have 2x plus 20, 2x plus 10. Now if you go back up to the original problem, it says the frame around the picture has a uniform width and an area of 400 square inches, which means the frame is 400 square inches, but that's not including the picture, which is 10 by 20, which gives you another 200 square inches. Now we're going to figure out our equation. So we did the picture. We're starting in the equation, which is indicator 3.2. So 2x times 2x is 4x squared. 2x times 10 is going to be 20x. 20 times 2x is 40x. And 20 times 10 is 200. 400 plus 200 is 600. Okay, now we're going to combine our like terms. We get 4x squared plus 60x, and then minus 400. This is the end of 3.2. We have our equation. Simplified it to be a quadratic equation. Now, 5.3, we got to solve it. Now, luckily for us, all these numbers, 4, 60, and negative 400, are divisible by 4. So we would have x squared plus 15x minus 100 equals 0. And this is factorable. Two numbers that multiply to be negative 100 but add up to be positive 15. 20 and negative 5. So that means x will equal negative 20 and positive 5. Well, since you can't have a negative distance, 5 is your answer. All right, next one. A rectangle has an area of 120 meters. This is a little bit different. Okay, if the length of the rectangle is 8 less than 2 times the width, all right, so the question is, what is the width? Does it say in the problem? The answer is no, it doesn't. So your width is x, it's an unknown. And your length is in terms of x. So it says the length of the rectangle is 8 less than 2 times the width. So let's kind of work backwards. 2 times the width, 2 times the width, because the width is x, and 8 less than that. There we go. So these are dimensions, x and then 2x minus 8. So we can multiply this out. X times 2x minus 8 equals, the whole area of that is 120 meters. Okay? So now we multiply everything out. We do the little rainbow method there. So you go x times 2x is 2x squared. X times negative 8 is negative 8x. I'm going to subtract the 120 to the other side so we can set it equal to 0. And there's our equation. So we made a picture, made an equation. Now we're going to go about solving it. Again, the nice thing about this is all the numbers we're given are all divisible by 2. So we have x squared minus 4x minus 60 equals 0. All right, let's figure out some factors of 60. And by, let's say, probably 10. 10 and 6, which has a difference of 4. So we have x, negative 10, positive 6. So x will equal positive 10 or negative 6. Distances can't be negative, so 10 would be your answer. However, if you look up to the question, it says find the perimeter of the rectangle. Okay? 10 is not the perimeter of the rectangle. It is what the x value is. So in that case, it would be the width. So if we look at our rectangle, okay, that's not a rectangle. Try that again. A little bit better. All right, our width is 10. Our length is 2 times 10 minus 8. So that's 20 minus 8, which is 12. Okay, which means that this side has to be 10, this has to be 12. So if you combine all those things to find the perimeter, you're at 24, 34, 44. So the perimeter is equal to 44, what are we talking about? Meters. And there we go. Next, our chemical mixture problems. Zoe has 40 quarts, 20% acid. How much of the solution must be poured off? If you're pouring something off, you're subtracting it. You're still subtracting a liquid that you're holding in your hand that is 20% acid. So that stays as 20%. How much we're pouring off, we're not sure, so we put it on next when we're not sure about something in math. Next, it says we're replacing it with pure acid. So we're in another bucket where they're replacing it. Pure must mean it's 100%. If it's not 100% and they call it pure, they're doing something wrong. How much we're replacing it with, we're not sure. Not told. So we're going to put X there. Then we're going to get a 60% solution. Now, what is the top number going to be? That's the big question. The top number always flows through these. So 40 minus x plus x means that there's no more x's because negative x plus x is going to be 0. You're left with 40. Okay, now we can multiply straight down. You're going to get 800x, sorry, just 800, not x, minus 20x plus 100x equals 2,400. So we did our picture for 1.1. We're doing our equation for 3.2, okay, which we just did, and then we do 5.1 in this case to solve it. So we're going to combine the x's to get 80x equals 2,400 minus 800 gives me 1,600. Then divide by 80 on both sides, so x will equal 20 quarts. Okay, last one. This one's a little bit more difficult. So Meg has an 80% oil solution. We're not told how much, just told the percentage. And a 50% oil solution. Again, how much? Don't know, it doesn't say. And then it says how much of each should we be mixed to create 100 cups of 63%. So we're mixing those two. We're getting 63. Okay, we're also told it's 100 cups. Now, if you think about what we were talking about before with the unknowns being variables, and then the top row makes your end number, you can also work backwards. Okay, we're not told how much is in the 80% solution. So when we're not told about something in math, we put down an x. Let's put an x. But if we put another x for the other unknown over the 50%, that won't make sense because the x's have to be the same number. So if we're dealing with 100, they're both 50, but they're not. How do we deal with that? So as I said before, these things all have to add up to be this, 100. So what do I have to do to add, what do I have to put on the top of the 50 to make sure that when I add it with the x, it gives you 100? Well, the answer is 100 minus x. If I do x plus negative x, that gives me 0, and I'm left with 100. So that's what we're going to use. So now we just multiply down. 80 times x is 80x, plus 5,000 for 550 times 100, and then minus 50x equals 6,300. So now my equation is done. Combine the like terms to get 30x equals 1,300, and divide by 30. X will equal, let's try this out, it's going to be ugly. Yep. So x will be 43.3. 43.3. And that, ladies and gentlemen, is it. All right. Have fun with the review, and I'll see you soon.